Now, this video is going to be sort of an application of the triangle inequality theorem. So far, the only question that we've answered with it is, does it form a triangle? Now, what we're actually going to do is determine what can the missing side be. So for instance, imagine I give you two side lengths, right? I'm already letting you know it is a triangle, okay? So for instance, I know it forms a triangle, okay? Or I want it to form a triangle. If I tell you one of them is equal to 9 and the other one is equal to 5, my question becomes, well, what can this side be equal to? Okay. You can do this using the circle way as well. You just have to be a little bit more intuitive with that one. But we're going to go ahead and first do it with the triangle inequality theorem, and then I'll try to explain using the circle one. Okay. So that's basically the game plan for this. And we're going to use the triangle inequality theorem. One of the most important things in this is that it does form a triangle. Okay. I already let you know. It's a yes, okay? So that means everything you know about the three inequalities, they must be true. And then the circles, if I were to draw it, they will intersect, okay? So that right there is probably the key part in this problem. Since it does form a triangle, what that means is that the three inequalities, right, from before are all true. So we can go ahead and we can actually create them and then see what they give us, because they're basically going to give us the answers. So the triangle inequality theorem states if you add two sides, it has to be bigger than the third side that you didn't include. So one of the inequalities is going to be 9 plus 5 has to be bigger than the third side that I don't know. And I can form three of them because I can choose two random sides. So I use 9 and 5. So now I'm going to use 5 and x. Now I know it's not a number, but just imagine it's a number. All we would do is add them, and then it would have to be equal to the last side that I did not do, okay, which in this case it's 9. Now I'm going to go ahead and do, there's 3, so I need one more. So choosing another 2, it'll be 9 and x. So 9 plus x is greater than 5. The only reason I can create these three inequalities is because of this right here, okay? Let's go ahead and let's just play around with these inequalities and see what ends up happening. So this is 14 is greater than x. This one's going to end up, if I can isolate the variable, and this just comes from solving inequalities from back in, I think, 9th grade or IM1 or pre-algebra, algebra 1. So this right here gives me x is greater than 4. And so then the last one, I can subtract the 9, and then that will give me x is greater than -4. And so then we have three inequalities here that I want you to sort of look at and see if you can make sense of them. The first inequality says that 14 is greater than x. Sorry, I should not write this right here because remember, it's only greater than, not greater than or equal to. So 14 has to be bigger than x. Okay, so just keep that in mind. That's what this one is saying. X has to be greater than 4. And then this one says, the last one says x has to be greater than -4. So one of the things that sort of helps me out here is let's create a number line. And let's, basically what I'm going to do here is I'm going to highlight all the different things that x can be. If you notice, we have a 4, we have a -4, and a 14. So I'm just going to really roughly go ahead and put these in the number line. So I'm going to put 0 here, I'm going to put -4, I'm going to put 4, and then I'm going to put 14 over here. Super not drawn to scale, but I hope you get the point, okay? So the first inequality right here, 14 has to be bigger than x. So what I'm going to do is I'm going to highlight on this number line what x can be. So if you notice, it's only a greater than sign, right? It's not a greater than or equal to. So what that means, it's going to be an open circle at 14. Open circle. And then since we're talking about x, okay, I'm trying to highlight what x can be. It has to be smaller than 14. So I'm going to go ahead and highlight over here, going to the left. And now going with the next one, which is going to be equal to the blue one, which is x is greater than 4. So again, it doesn't have a greater than or equal to, okay? So it's going to have to be an open circle. Greater than 4. And so what that means is that I'm going to go ahead and highlight to the right. And so then if you see it there, I sort of created this range where x can be. And now for the last one, which is, you're going to notice something. X is greater than -4. Okay, cool. So it's again greater than, so that means it's an open circle. X is greater than, so that means I have to, do the right here on the right. Now we get this sort of weird little thing right here on this side, and I'll tell you why it kind of doesn't matter. Let's imagine we put right here that this is X, this is -2. X cannot be -2. In fact, X can never be a negative number because we're talking about a side length here of a triangle, right? You have to keep going back to it. So what that means is that honestly, this one here, it doesn't really give us any information at all. It basically is just telling us, well, X is greater than -4, but then that means it can still be -2, -1. So in fact, it's really not valid when we're talking about numbers that fall over here in this section. Okay. What we want to look at is where are all the sections completely true. And the only sections that are completely true is, I'm going to go ahead and highlight that in yellow, is basically from the 4 open circle all the way to the 14 open circle. Okay, so that range there. And I know it looks super messy, but I'm just trying to explain here how to read this inequalities. The final answer is going to be one big inequality, which I'm going to go ahead and write in black, and hopefully you'll see here why it's easier than what it looks like. Okay, I was just trying to explain that. So the final answer, if you notice, it's dealing with the 4 and the 14, and it's saying anything in the middle of that. Okay, so what I'm going to do is put X in the middle of that, and I'm going to say it falls in between 4 and 14. And so then here, you can sort of see how I'm doing it. I'm just sort of flipping them just to make it one nice inequality. X has to be greater than 4, so I'm going to go ahead and just flip it so then it's, opened up to the X. And then we know from the other one, X has to be less than 14. So what I'm going to go ahead and do is just draw the inequality so that it'll still be X is less than 14. Okay. And so then we get this inequality here, and basically this is the final answer. This is the range of all our possible answers for X. It could be any number that lands between 4 and 14, non-inclusive. That means you cannot use 4, you cannot use 14, because it's only using this. It's not using these inequalities, okay? So just that there is the answer for it. I'm just trying to get you to understand it, okay? You don't need to do this number line every single time, but just understand that's where it's coming from. So let's go ahead to the next example, and then you'll see why it sort of makes sense. I just did this quick summary here. You can go ahead and read it, but it basically just summarizes everything that I've done. So two sides have a triangle, two sides of a triangle. So you see there, right there, that one, it already tells you, yes, they do exist. The triangle does exist. So find the range of possible measures for the third side. You notice there's no x, y, or anything, so you can just create your new one, your variable. I call it x just because. So same thing as before, 3 inequalities, and then get your range. Some of you can probably already tell there's a way easier method, but just we're using the triangle inequality theorem. So it'll be 7 plus 10 is greater than x, and then let's use two different numbers. 7 plus x is greater than 10, and then two other numbers. 10 plus x is greater than 7. Every single inequality is going to give us an equation, so that gives us that one. If I subtract 7 on both sides, it'll give us 3. And then if I subtract 10 on both sides, it'll give us -3. There's always one inequality that really won't give us much information, and it's really just the negative one. For right now, you can just see it as a shortcut. And so then we get these two here that are going to actually help us out. So what I'm going to go ahead and do is put x in the middle, because based off of the number line, I know it's going to be in the middle. Okay, and then we're sort of squeezing x in between two numbers. The two numbers are basically the smaller number, which is 3, and then the bigger number, which is 17. Okay, so x has to land between 3 and 17. That's how you would write it as an inequality. You can do it as a number line or anything like that, but just try to understand it like that. Now, one thing I do need you to understand, which I didn't talk about before, is can x be 2.9 based off of this inequality? The answer to that is no, because it does not fall in between that inequality. 2.9 would be somewhere right here, okay? And now if I would give you, it's just me trying to get you to understand how to read that inequality. And then can x be 16.999? Well, the answer for this one is going to be yes, because 16.999 would fall right before 17. Remember, it has to be less than 17. I know it's super close to it, but it doesn't matter as long as it's less. If, for instance, it's 17.000001, that is considered a no because then it's greater than 17 technically, okay? So let's go ahead and I'm going to just make up one last example just so we can sort of practice it. Some of you probably already noticed a super quick shortcut. And I mean, if you're really thinking about, well, aren't we sort of adding and subtracting? Yeah, that's the shortcut if you hadn't noticed already. So let's go ahead. Imagine that this actually does exist. Let's say I'll use, I don't know, 15, 7. No, let's use a different number. 15, let's use 12, and then I'll let you use a different letter, or I'll choose Z, whatever, okay? So try to do it, see what you get. The final answer is going to be Z has to be squeezed in between 3 and 27. You would just do this based off of the 3 inequalities or looking at the shortcut, but, you know, it's up to you. And that there is one application of the triangle inequality theorem.